The star is 4 light-years away. You've heard this phrase countless times, and if you're like most people, you probably think a light-year measures time. After all, it has the word year right in the name. But here's the truth: a light-year has nothing to do with time. It's a unit of distance, and understanding what it actually means will completely change how you think about the universe. Let's break down one of astronomy's most misunderstood concepts. The confusion is understandable. We're conditioned to think of years as measures of time. A light year sounds like it should mean the year when light arrives, or how long light takes to travel, but that's not what it means at all. A light year is a measure of distance. Specifically, the distance light travels in 1 year. It's similar to how we might say, it's a 2-hour drive to the beach. We're not measuring time, we're measuring distance using time as a reference. So when astronomers say a star is 4 light-years away, they mean, if you could travel at the speed of light, it would take you 4 years to get there. The star itself is a specific distance away in space, and we're expressing that distance using light's travel time. To understand a light year, we first need to understand light speed. Light travels at approximately 300,000 kilometers per second. That's 186,000 miles per second. At this speed, light can circle Earth's equator 7.5 times in a single second. In 1 second, light covers 300,000 kilometers. In 1 minute, that's 18 million kilometers. In 1 hour, 1.8 billion kilometers. In 1 day, 25.9 billion kilometers. Now multiply that by 365 days, and you get 1 light year, approximately 9.46 trillion kilometers, or about 5.88 trillion miles. To put this in perspective, the distance from Earth to the Sun is 150 million kilometers. Light covers that distance in just 8 minutes and 20 seconds. 1 light year is equal to 63,000 times the distance from Earth to the Sun. That's how vast a light year actually is. You might wonder, why use such a strange unit? Why not just stick with kilometers or miles? The answer is simple: regular distance units become useless in space. The numbers are too large to comprehend. Consider Proxima Centauri, the nearest star to our Sun. It's 4.24 light-years away. In more familiar units, that's 40 trillion kilometers, or 25 trillion miles. Try saying the nearest star is 40,208,000 kilometers away every time you reference it. It's impractical and incomprehensible. Light-years give us a manageable way to express cosmic distances. They also connect distance with something fundamental: the speed of light, which is the universe's speed limit. Nothing can travel faster. This leads to a profound implication. When we look at distant objects in space, we're looking back in time. The light from Proxima Centauri takes 4.24 years to reach us. That means when you look at that star through a telescope tonight, you're seeing it as it was 4.24 years ago. You're literally looking into the past. The Andromeda Galaxy is 2.5 million light-years away. The light you see from it tonight left Andromeda 2.5 million years ago, when early humans were just beginning to walk the Earth. Light-years aren't the only unit astronomers use for cosmic distances. Depending on the scale, different units are more practical. For distances within our solar system, we use astronomical units, or AU. 1 AU equals the distance from Earth to the Sun, about 150 million kilometers. Neptune orbits at 30 AU. The edge of our solar system's Oort cloud extends to about 100,000 AU. For very large cosmic distances, astronomers use parsecs. 1 parsec equals 3.26 light-years, or about 31 trillion kilometers. Parsecs are based on parallax measurements, the apparent shift in a star's position as Earth orbits the Sun, which is how astronomers originally measured stellar distances. You'll often hear about kiloparsecs, thousands of parsecs, or megaparsecs, millions of parsecs, when discussing galactic and intergalactic scales. The Milky Way is about 30 kiloparsecs in diameter. The nearest large galaxy cluster is roughly 20 megaparsecs away. But, for public communication and general understanding, the light year remains the most intuitive unit. It connects the cosmic scale to something we understand: the passage of time. Here's what makes light years truly fascinating. They remind us that distance and time are inseparable in the cosmos. When we measure the universe in light years, we're acknowledging that we can never see the universe as it is right now. We only see it as it was. The farther we look into space, the farther we look back in time. The most distant objects we've observed are over 13 billion light-years away. We're seeing them as they were just a few 100 million years after the Big Bang. So, what is a light year? It's not a measure of time, it's the distance light travels in 1 year, 946 trillion kilometers. It's our window into the past, our ruler for measuring infinity, and our reminder that in the cosmos, space and time are forever intertwined.